This video is a review of the slopes of parallel and perpendicular lines and how to write equations of lines that are either parallel or perpendicular to a given line with a given point that they go through. So first, let's take a look at the slopes of parallel and perpendicular lines. If we take a look at the two parallel lines shown in the first picture, the red line and the blue line, let's talk about how their slopes compare. So I have some points highlighted on these lines that we're going to use for our slope calculation. On the red line, we're going from -6, to the point 0.04. And so the change in y is going to be up 4 and over 6 to the positives. And so my slope of the red line is change in y over change in x, which is 4 over 6, and that reduces to 2/3. Now, if I take a look at the blue line, I'm using the points 0, -2, and +3, 0. So my change in y is up +2. My change in x is over +3. My slope of my blue line, change in y over change in x, is 2/3. The slopes of these two parallel lines are exactly the same. And slope measures how steep a line is. So because parallel lines have the same steepness, they will have the same slope. Now, if we take a look at perpendicular lines, how do their slopes compare? Well, again, let's start with the red line, and we are going to figure out the slope between the points -4, 0, and 0, 3. If I take a look at my change in y, it's up 3, so that's a change in y of +3, and my change in x is a +4. So my slope of the red line is +3 over +4, change in y over change in x. If I switch to the blue line, I'm calculating the slope between the point -6, 0, and 0, -8. That gives me a change in y of down 8, so -8, and I'm moving over towards the +6 units, so +6 for my change in x. My slope of my blue line then would be -8 over +6, which reduces to a -4/3. These slopes are not exactly the same, but they are related in some way. They are opposite signs, one's positive and one's negative, and that makes sense because my red line's going uphill, my blue line's going downhill. And they are also reciprocals of each other. 3/4 and 4/3 are reciprocals. A reciprocal means we're flipping the fraction. Perpendicular lines have slopes that are opposites, meaning opposite signs, and reciprocals, meaning we flip the fraction. Now, how can we use this information about slope to help us write equations for pairs of parallel and perpendicular lines? Well, we use y equals mx plus b to help us write equations of lines. When we use this equation, we need the slope, which is represented by m, and the y-intercept, which is represented by b. So in each of these problems that follow, that's going to be our goal. Figure out the slope of our new line and figure out the y-intercept of our new line based on the information given for the original line. So in the first question, we're asked to write the equation of the line parallel to this given line. Okay? Remember, if lines are parallel, that means they have the same slope. So for our new line, we know it's parallel to the old line, which means they have the same slope. If the slope of my old line is 4/3, the slope of my new line should also be 4/3. And I know my new line passes through the point 0, -3. There's something special about the way this point is written. Because there's a 0 in the x spot in the coordinate, this is a y-intercept. That's a giveaway that this is a y-intercept. So that means I'm given my y-intercept of my new line right away, and it's -3. The equation I'm looking for is 4/3 x minus 3. In the next problem, we're writing an equation for a line perpendicular to this given line. Perpendicular lines have slopes that are opposite reciprocals. So if I take a look at my old line, the one that's circled, my slope is a +3. That means my new line, which is perpendicular to it, is going to have a slope, and I'll put this little perpendicular sign by the slope so we know it's for the new line. It's going to have a slope that's the opposite sign, so I'm going to go from positive to negative, and the reciprocal from 3/1 to 1/3. Take a look at the point that my new line is supposed to go through. Again, I have a 0 in the x spot. That means I am working with a y-intercept. And so the y-intercept of my new line is a -2. The equation that I'm looking for is y equals a -1/3 x minus 2. Now, what happens if we need to write the equation of a line that's parallel or perpendicular to a given line, and the point we're given is not the y-intercept? Well, let's take a look at the next one. Write an equation for a line parallel, so we're looking for the same slope, to y equals 2x minus 12, passing through this new point, -1, 6. All right, so my new line, I need to figure out its slope and its y-intercept. The slope of my new line should be the same as the slope of my old line because they're parallel. My old line has a slope of 2, my new line has a slope of 2, okay? How do I find that y-intercept? Well, I know this new line goes through the point -1, 6. And if you remember back to Algebra 1, we have the slope, we have an x value on our new line, we have a y value on our new line. If we plug those three things into y equals mx plus b, we'll be plugging something in for y, for m, for x, and we can solve for the y-intercept of the line. Let's do that, okay? A y value I know on the line is 6. The slope is 2. I know the line has an x value of -1 when y is 6, and I'm looking for that y-intercept. And so now I'm just solving this equation. I'm going to add 2 to both sides, and so 8 is equal to b. So b is 8, and the equation of the line parallel to 2x minus 12 that goes through the point -1, 6 is y equals 2x plus 8. For the last example, we're going to write the equation of a line perpendicular to y equals -3x plus 4 that passes through the point to -5. So again, let's make a little list of what we know and what we need for our new line. Our new line is going to have a slope that's the opposite reciprocal of the line we're given. So my old line has a slope of -3. My new line is going to have a slope that's positive then, opposite sign. If the first line is negative, my new line is positive. And it's going to be the reciprocal. So instead of 3/1, my new line has a slope of 1/3. I still need that y-intercept, and I do know that the new line passes through the point to -5. And again, remember, that gives me an x to work with and a y value to work with on the new line, as well as the slope. So how does that help me? Well, if y equals mx plus b, I can take the y value that I know from the coordinate, the x value that I know from the coordinate, and the slope, plug them in, and solve for my y-intercept b. My y value is a -5. My slope is a positive 1/3. My x value is a positive 2. And I'm going to solve for b. And yes, we can work with fractions here, okay? -5 equals a positive 2/3 plus b. Remember, numerator times numerator, denominator times denominator. Now if I subtract 2/3 from both sides, -5 take away 2/3, okay, that's going to give me a negative 5 2/3, which is a negative 17/3. That equals my y-intercept b. And so the equation of this new line that's perpendicular to -3x plus 4 and passes through the point 2, -5 is y equals a positive 1/3 x minus, and that should be a negative 17/3, minus 17/3. So now that you've watched this video, I want you to try the 8 practice problems that I included in this homework tab for you in Google Classroom, and this will be part of your assignment on your asynchronous days this week. Good luck, and let me know if you have any questions.